Okay, example 3. So example 3 looks at a smooth bead threaded on a light inextensible string. So here in the diagram, this is the bead, Y, which is just a particle. Bead just means modelling it as a particle, and the string is going from X to Z, and you've got to imagine Y is along it, like some sort of wristband or something like that. And so this bead can move along the string, right, and it can pull the string out, and the string's attached there, so there's going to be some tension in the string on these 2 points here. Now, the thing to remember about string is that when you have the tension is the same all of the way along the string. That's true in all of our assumptions in mechanics, in normal maths, and it comes from the fact that the bead is smooth. So as long as the bead is smooth, the tension will be the same all the way along. If there was friction there, and it wasn't a smooth bead, it was a rough bead, there's going to be some change in one of the tension forces. But for the sake of this, the tension will be the same in all of the parts. It tells you the bead is held in equilibrium again, so we know the forces will balance. There's a force of magnitude 8 acting to the left, and it asks you to find the tension in the string and the weight of the bead. So the first thing I'm going to do, I'm going to annotate this picture a little bit. So the tension is trying to pull the bead up, right? They're the bits holding the bead up on the string. And then we've got a force weight pulling it down. But let me just redraw that with the bead at the centre of our diagram, right? Because that's what we're bothered in. So we're only interested in forces that are affecting our bead. So we've got the 8 newtons there, we've got the weight here, and then the bead is experiencing the tension up, and the same tension force going like that. And we have to have the angle that this makes. So if we look at this, right, we could see, well, it's a triangle actually, so we could put the 60 in here. Okay, and when you've got that diagram, it turns into a question that is just then exactly the same as what we've done in the previous lesson. So the key point was that the tension had to be the same all the way along the string. And then we're going to resolve. We're going to resolve vertically, and we're going to resolve horizontally. So what's pulling it up in the positive? T is pulling it straight up, that's this T here. And this T is pulling up by an angle, so we have to go through the 60. So this is a T cos 60. This is equal to the weight, which is pulling us down. So 2 unknowns there, you've got the T and you've got the W. I can resolve horizontally, taking the direction to the right as positive on the first side. So this is T. We go away from the 60 now to get to the horizontal, so it's sine 60. This T and this W have no effect in the horizontal direction, so it's just my 8 newtons that's going to balance with. And that's perfect because our green equation here only has one unknown, right? So we've got T sine 60 equals 8. So we know that T must be equal to 8 divided by sine 60, which gives us 9.24 newtons to 3 significant figures. And then we just have to find the weight. And to find the weight, we're going to substitute into that top equation. Okay. So this is T plus T cos 60, so it's going to be 9.24 plus 9.24 cos 60 equals W, and of course I'm still going to use the full calculator accuracy of my previous answer. And that gives us 13.9 newtons to 3 significant figures, and that is the weight of the bead.